So you think Wi-Fi 6 is fast? Well, get ready, because the next big evolution in wireless is already here. Today, we're diving deep into the groundbreaking standard known as Wi-Fi 7. Its official name is 802.11b, and yeah, that's B then E. And it's not just a small step up, it is a massive leap forward.
Now, before we jump in, all the great info we're covering today comes from a super detailed report on Wi-Fi and Bluetooth standards by the folks at RFI Detectives who are part of Virtualization Options LLC. This is actually part 17 of our 20-part series breaking down their findings, and today it is all about Wi-Fi 7. All right, so here's our game plan. First, we'll talk about the why, like what problems actually needed solving. Then we'll geek out on the core technologies, especially this incredible feature called multi-link operation. After that, we'll look at some other boosts to capacity and efficiency before we get to the big one. What does all this tech actually mean for you in the real world? Okay, let's get right into it. You might be thinking, hang on a second, Wi-Fi 6 is already crazy fast, right? We're talking multi-gigabit speeds. So what gives? Why the massive push for something even more powerful? Why did we even need Wi-Fi 7? To really get the scale of this change, you have to look at the history here. I mean, we started way back in 1997 with just 2 megabits per second. Fast forward to Wi-Fi 6, and we hit a very respectable 9.6 gigabits. But then you get Wi-Fi 7, also known as 802.11b. We are talking about a theoretical maximum of 46 gigabits per second. That's not just an upgrade, that is a whole different ballgame, a monumental jump in raw capacity. And that brings us right back to that critical question, especially for all you IT pros listening. We already have this speed with Wi-Fi 6. It handles most of what we can throw at it today, right? So what was the problem? What was so broken that we needed Wi-Fi 7 to come in and fix it? And here's the answer. The core mission was never just about being faster. The goal was to deliver 2 key things: extreme throughput, of course, but also ultra-low deterministic latency. And that word deterministic, that's the magic word. It means predictable, reliable, consistent, the kind of rock-solid performance you only used to get from plugging in an Ethernet cable. For wireless, that's the holy grail. So, that's a pretty ambitious goal, right? How on earth did the engineers pull it off? Let's pop the hood and take a look at the core technologies that make Wi-Fi 7 tick. First up, a big one. It's all about how wide the communication channels are, and Wi-Fi 7 introduces absolutely massive 320 megahertz channels. Just to put that into perspective, Wi-Fi 7 literally doubles the maximum channel width from Wi-Fi 6. The easiest way to think about it is like a data highway. If Wi-Fi 6 gave us a nice wide 160 megahertz highway, Wi-Fi 7 just came along and doubled the number of lanes. It's that simple. More lanes means way more data can get through at the same time. Okay, so we've doubled the lanes on our highway, but what if we could also pack more stuff into every single car and truck on that highway? Well, that's exactly what Wi-Fi 7 does, using a technology called 4096 QAM. So what the heck is QAM? Well, think of it as how much data you can cram into a single wireless signal. With Wi-Fi 6, we had 1024 QAM, which let us pack 10 bits of data per signal. Now, with 4096 QAM, we're cramming in 12 bits. It might not sound like a huge jump, but it means every single transmission is way denser and more information-rich, making the whole thing much more efficient. Now, wider channels and denser data are great, but if there is one single feature that you need to remember about Wi-Fi 7, it's this next one. This is the real game changer. Let's talk about multi-link operation, or MLO. This is a fundamental shift in how Wi-Fi works. You know how your device usually picks one band to connect to? The 2.4, the 5, or the 6 gigahertz band? Well, MLO blows that idea up. It lets a single device connect and transmit data across multiple bands at the exact same time. It creates one single aggregated connection that is not only way faster, but also incredibly resilient. And it's smart about it too. It's not a one-size-fits-all approach. For your high-performance devices, there's STR, or simultaneous transmit and receive. For devices where radios might interfere, there's a non-simultaneous mode, NSTR. And for all those little battery-powered gadgets like phones and IoT sensors, there's a special power-saving mode. It's incredibly flexible, designed to work with anything you throw at it. MLO is obviously huge, but Wi-Fi 7 isn't done yet. It has a few other clever tricks up its sleeve to manage the network more efficiently. It's not just about building a bigger highway, it's about adding a smarter traffic control system. Take something called multi-resource units, or MRUs.
In Wi-Fi 6, we could slice up a channel into little pieces for different devices. Wi-Fi 7 improves on this by letting a single device use multiple of those slices at once. This basically fills in all the little unused gaps in the airways that would otherwise go to waste, squeezing every last drop of efficiency out of the spectrum. Wi-Fi 7 also doubles the number of available spatial streams, from 8 all the way up to 16. But hold on, this doesn't mean we're about to see laptops with 16 antennas. No, the way this gets used is, well, it's a lot cooler than that. So here is the magic. Instead of one access point trying to manage all 16 streams, this power enables something called multi-AP coordination. Imagine all the APs in your building start working together. They coordinate and time their signals perfectly to focus a single, powerful beam directly at your device. They essentially form one giant virtual access point, delivering an incredibly strong and reliable connection across a huge area. Okay, that's a lot of impressive tech talk, but let's bring it all back down to earth. So what? Why does any of this matter to you and your daily operations? What can we actually do with all this new power? And this is the whole point. Wi-Fi 7, and that's 802.11b, is built for the applications of tomorrow. We're talking about high-fidelity extended reality, where a single millisecond of lag can ruin the experience. Industrial robotics that demand the reliability of a wired connection. Cloud gaming that feels instantaneous. Streaming multiple 8K videos without a single stutter. These things don't just need more bandwidth, they demand that deterministic, ultra-low latency we've been talking about. Ultimately, when you boil it all down, this is the big takeaway. For the very first time, Wi-Fi can deliver a level of performance, both speed and reliability, that we used to only get from a physical Ethernet cable. It's about getting true wire-like performance with all the freedom of being wireless. And that's what I really want to leave you with. As IT leaders and network engineers, the question isn't just what is Wi-Fi 7, but rather, what can we do now that was impossible before? How will having access to this extreme throughput and truly deterministic wireless latency change the way your business operates? That's the brand new frontier the standard is opening up for all of us.